until they get to the final piece, or we're trying to put it all together. So what we're doing is we're working very hard to change that. And we're using the general systems model, input, process, output. And I see a number of you that had already started moving in that direction. In fact, that's why we're here at High Tech, because somebody grabbed us and said, you know what, we're already doing this, and you need to come here and talk a little bit about towards that. Using the general systems model, we're now teaching a process. And as we discussed earlier today, technicians can go anywhere. And we're finding this at Skills USA. I don't believe there will be an electronics technology, pure electronics technology event very much longer at Skills USA. Because electronics is touching so many other events. We may be an element of a number of other events, but I don't believe we will be an event of our own. And so when you're developing or building your electronics program, keep that in mind. Electronics is not pure anymore. It spreads out everywhere, and everyone needs some electronics. But what if we taught the process with the inputs, the outputs, and the feedback mechanisms, and then once just on any system, a generic system, get the students used to a system, get them to play with it, let them be operators for a while, and then go, you know, oh, by the way, the thing that makes this thing run, it's a power source. And it may be a DC power source, it may be an AC power source, there may be some ways to manipulate this through math and physics. Let's teach it then, just in time. Now we're applied, now we understand where we're going. And I think you'll find a much more rounded student. Had the skills students worked from this piece, they would have probably aced our program. Because that element, the troubleshooting element of our skills program, was based on a systems approach. Anybody know Mark Taylor? Anybody seen anything from Mark? Dr. Mark Taylor, I think he's out of the University of Arkansas, has written some phenomenal papers and has it's public speaking around the globe. In the back of your packet, I have his website, and he has two very recent papers about changing the way we teach today's students. And although he is not a technology guy, he has presented in front of just about every career field that you can imagine. A lot of medical area, a lot of technology. I saw him at the Aviation Technical Education Conference in Orlando. And his claim, or his whole focus, and I wrote it down in here, but he moves the faculty from the traditional method of delivering content in class and expecting students to apply that content out of class to moving the content out of class and doing all the application in class. And technology programs try to do that. But I still go to school after school after school where the primary driver is lecture, doing exactly what I'm doing. And you're going to lose today's student. Generation Next is what they call it. And wait till Generation 2.0 comes up, because you'll never be able to hold on to them with a lecture-based program. Now we find this in the military because we're working with a group, and military is typically easier to change. And they have the opportunity, or because they don't really answer to anybody but themselves, they have the ability to change methodologies of training and try different things. So we've been doing what we call active learning in military situations for years now. We need to start moving that, and I know we already have, but this really needs to be the norm, not the exception, in schools, in public schools, in private schools, in technology schools. Moving the content out of the classroom means putting the onus of learning on the student. They love going into podcasts. If you put your theory, your facts, concepts, and principles in a podcast type delivery system, that's their assignment. Webinars, we work with webinars quite a bit. Have them do research projects. Dr. Gunn, that was what she had her students go out and interview people in that field and come back and do peer learning. Outstanding, way ahead of the curve. Because when you have your students do the content outside of class, they have to come to class prepared. But you have to be prepared to say, nope, you're not doing the application if you're not prepared, and send them on their way. Only those that have earned the application should be participating in the application. Feedback, now there's a number of ways to determine if they actually got it or not. Pop quizzes, I mean, that's always been a good one. A lot of peer learning really helps. Have them take a piece of the subject. And we were talking about, I think one of the questions that came up was the instructor, the technology is moving ahead so quickly, instructors can't keep up with it, and therefore, not to mention jobs right now, because there are so few technician jobs or technician areas. If you're in the nuclear industry, as an entry-level nuclear technician, you'll make more money than your professor, without a doubt. Hard to keep professors that way. So what you can do is you can put the onus of learning on the student and use somebody that has a broad perspective, maybe not be the subject matter expert in nuclear, but has a broad background so that they can facilitate a program. Yes?
BT, that's the
BT. Computer-based training, should be CBT. But I put that up there to see if anybody was paying attention. All right, we work a lot with a company called Turtle Rattle Incorporated. And what Turtle Rattle does is they take military programs primarily and determine problems and make them more efficient, more effective. They're working on one in the UK, and this will be a real good one for all you materials people that was just in this last seminar or last workshop. They went to the UK. These are the guys that do the materials, the metals, the welding, the fabrication for the United Kingdom, all the defense forces. They went in and looked at their program. It was 90% lecture-based. Now, I could tell you how to weld all day long. You're probably not going to do a very good job. Now, they did get several hours in the welding booth welding. But when they got out to the field, they had no experience of welding in the field. And this was kind of interesting because the #1 requirement in Afghanistan for a UK fabricator, anybody guess?
welding.
In the Middle East, in Afghanistan, fixing gates. Those gates get run down weekly. So they would bring this person right out of school and give them a torch and a welding, and I'm not a materials guy, so I'm not exactly sure what they do, and they couldn't fix the gate. They'd never done that before in their life. They could go into a booth and run a bead, but that was the extent of it, and they were expected to get all of that training in the field, and the UK doesn't have that many people. So they don't have that many people in the field. So what this company did was they came in, what Turtle Rattle did is they came in, and the very first day the students arrived, they're cutting things up. The second thing they did was they had a project where they actually had to build a gate very similar to what they would do in the field. The naysayers, those that were supporting lecture as the primary mover, said, nope, safety issue, they can't be outside in the rain, and it rains all the time in the UK. True story, huh? So what they did was they stalled it. And they said, see, this program doesn't work because we can't have our guys working out in the rain. So Turtle Rattle said, well, why can't they work in the rain? The day they graduate, aren't they going to be expected to work out in the rain? Exactly. So what do they have to do when they get out into the rain? Well, they have to do a risk assessment, and when they're finished with the risk assessment, they put into those items that they determined in the risk assessment, and they weld in the rain. And that's exactly what they did at the school. Students, now this particular chart was taken from the U.S. Navy. The U.S. Navy now trains every one of their electrical and electronic technicians using active learning. When they first started doing this, they started gathering the information. And what they have found was students did far better and graduated from their programs in 63% of the time on average than students going through the old program, the dependent learning program. What they didn't expect and what they found was students going out into the field were active workers and not dependent workers. So it was really kind of amazing. So we've done a lot of that. All right, while we're talking about changing and tweaking our programs, there's a lot of push for virtual everything. virtual materials is initial upfront cost, but typically, I mean, you can save some bucks if you go virtual with everything. There's one university, it's an aeronautical university that we work very closely. If you know where NIDA is, they're 50 miles north of us, but I won't say who they are. They had an inspector come in, and he was just from the FAA, and he was just walking through their program, and he noticed that one of the students was using a ratchet wrench, and he was putting it on the engine bolt and turning the ratchet wrench, lifting it off, putting it back on, and he asked the student, well, how, you know, you went through tools, right? Tools was 100% virtual. It was all point and click. Well, since then, I mean, it was an embarrassment to the school, but since then, they fixed that problem. And they do a lot of hands-on. And unfortunately, this was really unfair to the student, because it was the first thing they had done after getting out of the tools section. It was the first thing that they had done in the shop. So I'm sure somebody would have corrected that pretty quickly. But the point I'm trying to make is back in the old days, prior to World War II, everything was hands-on. In fact, you didn't go to school. If you wanted to be an apprentice of some kind, you worked with a journeyman and you worked your way up. Around the 1940s, late 40s, when all the men were coming back from World War II fighting overseas, they started putting schools together, technician schools. And primarily, it was a lot of hands-on. Then in the 1980s, we discovered computing. And we discovered, hey, we can do some pretty cool things with this. At the time, I was a training officer at the Coast Guard's Aviation Technical Training Center. And we jumped on the virtual bandwagon in a very big way. In fact, when we structured our Jayhawk program, which is the H-60 helicopters, the maintenance program, it was virtually all virtual. Students would go in and click on a panel for troubleshooting. The panel would open up. They could click on the pump would explode. They would change parts or whatever. We sent them off to the field, having really never removed the pump from an H-60. We went way too far the other way. So what we're asking, or what we're recommending, is a great balance or blend between virtual. Virtual is outstanding, but pretty soon, you got to work on the gear. You've got to at least get your hands dirty. You've got to weld something. You have to put your probes in a circuit because you're not going to shock yourself if you're doing it virtually. Hopefully. Hopefully. All right, systems analysis. This is what we need to do. We need to re-look at how we're training our technicians. We need to make better troubleshooters. And by a systems thinking approach, you're able to develop these students that will go out into the field, any career, because the systems approach really is a methodology for troubleshooting anything. And we're not too far from here. You know that MIT has devised a cloaking device, and that's probably the last time you saw a cloaking device. They actually have devised a cloaking device that works. It's very small scale right now, but it takes a radar signal, bends it, moves it out, brings it back, bends it, and so the signature is whatever's on the other side of the item that they're trying to hide. I swear I have that on my Volkswagen because people are always ready. I can't turn it off, but that's not a problem. All right, I talked a little bit about the what and why of systems thinking and systems analysis. This afternoon, Dr. Kohler is going to provide the how. And I really, if you have an opportunity, you need to kind of come back here and take a look at that. There'll be all sorts of stuff that he's going to provide for you. All right, a very wise man. And I don't usually read my slides, but I'm going to have to in this case. We cannot solve problems using the same kind of thinking we used when we created them. I love this guy. Now, another guy that I think very highly of also says we cannot train and maintain today's technicians using the same methodologies that were used to teach us. In fact, if the methodologies used to teach me as a technician of the 80s, 70s, 80s, it wouldn't work today. So we need to be moving forward. Our students have already done that. All right, I thank you very much. Are there any questions?
I have a question.
Yes.
Can you just explain a little bit more about how the afternoon session is different than this session?
We
coordinated on this. We're going to start where he left off and go back and review very briefly the systems model and move to how in terms of the different technologies that we put in place. And we focused on all the ones we could find that we're currently using that are free. There are going to be 15 tools in your tool bag when you leave this afternoon. You can use them or not, but we decided not to try to tell you about the curriculum because that's what you do. But we have a bunch of techniques that we'd like to share.
Thank you.